Hi everyone, welcome back to my channel. Today we're gonna work on the question unique binary search trees 2. The question states, given an integer n, return all the structurally unique BSTs, which has exactly n nodes of unique values from 1 to n. Return the answer in any order. So this question, 1 to n, the root, we immediately know that the root could be, like if n equals 3, the root could be 1, 2, or 3. So under the case that the root equals 1, there's 2 nodes to the right of 1, so the second node here could either be 2 or 3. So in this case, we picked 3, so then 2 is to the left of 3. So then after we do 2 to the left of 3, we want to backtrack here to the other option, which is 2. So we see 1, 2, 3. 3 is now to the right of 2. So when 1 is the root, there's two possible BSTs. And when 2 is the root, as you can see, there's only one node to the left of 2 and one node to the right of 2. So there's no other options than 2, 1, and 3. So there's only one BST here. And when 3 is the root, there's again 2 to the left of 3. So there's two options for the second node here. It could be either 2 or 1. So 3, 2, 1, or it can be 3, 1, 2. So in total, there's 5 unique BSTs if n equals 3. Let's try to write this in code. Since we're in the recursion chapter, I'm going to try to solve this using a DFS. So my DFS is going to take a start and end, and it's going to have a base case. If start is greater than n, then we return none. And let's feed our DFS the data. So return DFS 1 to n. So as we talked previously, there's 3 possible roots for n equals 3. We want to go through all of the numbers 1 to n, and we make each of them as the root. So for I in range start to n plus 1, we want to do n plus 1 because the range function doesn't include the last number. It has to be n plus 1 in order for the n to be included. So I would be our root each time, and we want to determine what's left of I and what's right of I. So everything to the left of I is DFS start to I, and everything, I minus 1, and everything to the right of I is DFS I plus 1 to n. Then after we found all of the left parts of the tree and all of the right parts of the tree, we go through all of them, because there could be multiple left parts of the tree and we want to loop through them. So for L in left, for R in right, we can do the current root equals the tree node I, and then current root dot left equals L, and current root dot right equals R. Let's make a list for our final answer for all of the BSTs. All trees equals list, and we can append this to our all trees. And in the end, we want to return all so return all the unique BSTs. Let's try running this. Yeah, so this is how I would solve this question using a recursive DFS. Let me know if you have any questions, and thank you so much for watching.